About active problem, chapter 14, number 15, and how to put that in. So first, let's figure out how to work the problem, and then we will look at how to put that calculation into active. Okay, so we're starting with 0.0720 grams of C2H6O2, and that's ethylene glycol per gram of solution. And we're told that the density of this solution is 1.04 grams per milliliter. So we've got grams of C2H6O2 per gram of solution. And we need to convert that to molarity. And remember, molarity is moles of solute per liter of solution, right? And so we need to convert that to moles of ethylene glycol per liter of solution. But we're starting with grams of ethylene glycol per gram of solution. So we'll need to convert our grams of ethylene glycol to moles of ethylene glycol. And we do that through the molecular weight of ethylene glycol. And we can get that from the periodic table. Remember, the molecular weight is 2 times carbon plus 6 times hydrogen plus 2 times oxygen. And if you calculate that, we get 62.08 grams of ethylene glycol per mole of ethylene glycol. Okay, and then we're going to convert moles of ethylene glycol. We're going to convert grams of solution to milliliters of solution, and we can convert mass to volume through the density. All right, so next we're going to convert grams of solution to milliliters of solution, and we're going to do that through the density. And then once we have milliliters, we'll need to convert milliliters of solution to liters of solution. Okay, liters of solution. And we're going to do that through the conversion factor. 1,000 milliliters is 1 liter. Okay, so let's go ahead and get started. We've got 0.0720 grams of C2H6O2 per 1 gram of solution, right? Next, we're going to use the molecular weight. That's 62.08 grams of ethylene glycol. That's our C2H6O2 per mole of ethylene glycol. Now, that's what we needed in the numerator. We need moles per liter of solution. So we have our moles of ethylene glycol. Now we need to convert grams of solution to volume of solution, and we do that through the density. 1.04 grams of solution is 1 milliliter of solution. Okay, and now we have 1,000 milliliters of solution is 1 liter of solution. And now we have liters of solution in the denominator. If you put that in your calculator, you get 1.21 moles of ethylene glycol per liter of solution, and that's equal to the molarity of our ethylene glycol solution. Let's see how we can put that into active, okay? So how are we going to put that? We're starting with 0.0720 grams of ethylene glycol. So let's put that in, 0.0720. And next we have grams of ethylene glycol, okay? That is an issue there. Grams of ethylene glycol per gram of solution. So you have to put this as your starting amount. Okay. And our next factor is the molecular weight, 62.08 grams per mole. So 62.08, we need that in the denominator. Grams of ethylene glycol per mole of ethylene glycol. All right, we need to add a factor, and next we have the density. So we've got 1.04 grams of solution. Right, grams of solution per 1 milliliter of solution. Now we're going to add a factor. All right, we've got 1,000 milliliters of solution. All right, per 1 liter of solution. All right, and that's going to be equal to 1.21 moles per liter. Let's see. Or molar works too. Molar. And when I pull that in, that just gave me moles per liter for our molarity, and that's what we were looking for.